So, good evening and welcome back. Good to see a lot of your names after a long time. As you know, by the way, am I audible? I'm sorry for my voice. I have just recovered from a severe cold. So, can you all hear me? Voice is clear, right? Yes. Okay. Thank you. All right. So, very sorry. This is our revision class just before your exam. So next week you have your exam, and we're just going through. We'll just be going through some revision topics. And what I have decided to do today is I'm going to take a couple of problems. I am not doing a lot of problems, but I have just chosen a few problems which I feel will be helpful uh, for your class. And at the same time, while we do those problems, I'll also be while we do the problems, I'll also be revising some things that related to the topic, which I feel is good just to repeat, so that you remember that in time for the exam, right? So this is just a brief, like a regular lecture, but instead of focusing on one topic, we'll just try to do a lot of sample problems. Okay, some of these are PYQs, some of these are not PYQs, but all of these are, like, I've chosen them for to illustrate some or the other point. Okay, so the first problem we'll start with is a problem on diodes. Yeah, this is the first problem. All right, I'll read the problem. In the question, a circuit and a waveform for the input voltage is given. The diode in circuit has cut-in voltage V gamma is equal to 0 volts. What does V gamma equal to 0 volts imply? V gamma equal to 0 means that your diode is a ideal diode. Okay. Next, choose the option for the waveform of the output voltage V. Very obviously, since they have asked you a waveform question, okay, if you ask, like if the question is on waveforms, very likely it is from clippers and clampers. All right. So first thing we need to do in such a question is, very first thing we need to do is our circuit a clipper or a clamper? Can anyone answer that in the chat or unmute? Do you remember? Is this a clipper or a clamper?
It is a clipper.
Yeah. How do you identify? The easiest way to identify is a circuit only has resistors and diodes is a clipper. A circuit which has resistors, diodes, and capacitors, that kind of a circuit will be a clamper circuit. Okay. So in this case, we will just have a clipper circuit. So now, if you notice, a clipper has to just clip the circuit, right? It has to clip the waveform. Now, how do we analyze this circuit? Now, I told you the original method to do it. The right method to do it, you analyze the positive half cycle separately and the negative half cycle separately. However, that is slightly time consuming, and I had given you a simple trick to do that. Okay, if you remember, I had given you a simple trick. What was the trick? Look at the node where the diode and the resistor are connected. Right, look at the node and see what terminal of the diode is connected here. All right, so if you see, this is P, this is N. If the N terminal is connected, that implies that this is a negative clipper. Negative clipper. So first thing we know is it is a negative clipper, and it is going to clip the negative part. Negative part means some part of the circuit from below is going to be clipped. That is what we know for sure. First thing. Second part of the trick was, you go in the clockwise direction. Once you move in the clockwise direction, see which voltage you strike. This should be apart from the input voltage. Okay. So if you go in the clockwise direction, apart from input voltage, you see a plus 5 volt source. You see a plus 5 volt source. So we usually call that as our axis, plus 5 volts. Okay. So what is going to happen is, we can just draw a line of plus 5 volts, right? We can just draw a line for plus 5. I think plus 5 will be somewhere here, and everything below this line has to be cut. Okay, negative clipper का मतलब है कि नीचे का पोर्शन कट होगा, नेगेटिव पोर्शन, और एक्सेस 5 वोल्ट है, मतलब 5 वोल्ट के नीचे जो भी है वो कट हो जाएगा. ओके, सो इफ ऑल दिस गोज अवे, all this goes away, what is left? You have a waveform which is just from 20 to 5. And which of the options match? Option D is the correct option. Option D is the right one. Is this problem clear to everyone? Yes. Okay. Anyone has a doubt, please ask me. Else, but please write these problems. Okay, please write these problems in your notebook. Don't just sit and watch it as just some lecture or some online video. Please write it down as I write, so it will help you. Just give you 2 minutes to write it and draw it. So remember the trick. The trick will really help you to do things quickly. And what will happen is, since we have an MCQ exam, you will be able to eliminate things very quickly. In this problem, of course, we could not eliminate. Option A cannot be true because it is going up to -10. So there's no way waveform can go up to -10 in a clipper circuit. In a clamper circuit, yes, not in a clipper. So A is not possible. Any of the other options were possible, but of course it turns out that option D is right. Another thing is for the exam, for the upcoming exam, please ensure that you read the question carefully and the options as well. Okay, read the questions, read the options, and then you solve it. It usually it helps a lot. Some of the options are might be like ridiculously wrong, so immediately you have narrowed down one option. Okay, so reading the options always helps. I don't remember which paper this was exactly, and I don't remember the question as well. It was, I think, some mechanics question, but it was a JEST paper where they had asked, what is the time? What is the time? And in all the options, there was only one option which had the dimension of seconds. So basically, though it was a mechanics question, there was no elaborate solving required. I don't remember which year this was, but so please read the options carefully. Yeah, once you all finished writing, please let me know. Yes, have you all finished writing? Done. Okay, thank you. All right, let's take another question. Let's take another question. Uh, Good question. Yeah, this is problem number 2. Yeah, second problem for today. What is this circuit? This is also a clipper circuit. Okay, no capacitors, right? No capacitors. So this is a clipper circuit. Oh, 1 minute. I didn't give you the options. Anyways, the options are not super important, but still, you just paste them on the screen so you know. Yeah, these are the options. Okay, this is the question, and these are the options. Now, what is going to happen is this waveform will act on both of these, like both these diodes will individually induce an effect. दोनों के दोनों diodes अपना काम अलग अलग तरीके से करेंगे. Can we use the trick in such a problem as well? Perfectly, we can use it, use the same trick. Let's look at D1. If you look at the first diode, this diode D1, this P and N, this is P, this is N. Since P type is connected, this will become a positive clipper. This will become a positive clipper. Okay. What does a positive clipper do? It cuts the positive part. And this second clipper, if I take a different color, here if you see, this is P, This is N. N is connected, so this is a negative clipper. So this is going to end up connecting a, this is going to end up cutting a negative part of your waveform. All right. Now let us check the axis. For D1, if you go clockwise, you see plus 8, plus 8 volts. And for D2, again, I use a different color. If you go clockwise, you see minus 6 volts, minus 6 volts. So the positive clipper should cut everything above plus 8 volts, right? And the negative clipper must cut everything below minus 6 volts. Somewhere over here will be minus 6. Now, which of the waveforms matches? Positive, it should clip at 8, and negative, it should clip at minus 6. So option C is the only one, and option C is the right answer. Option C will be the right answer. Is that clear? Yes?
Yes, sir.
Okay. Just quickly sketch the waveforms and write the question. These are just I have not taken questions from all different all different topics. That will become too much. We won't have that much time. But some important topics that just I feel you might benefit. Again, just a very quick summary of what we have been doing, like in electronics. We have 4 major chapters. Okay. In analog, we have diodes, BJTs, and op amps. And digital, the whole section is one section. So right now we are doing diodes. In diodes, we have 3 things. One is pure diode circuits, Zener diode circuits, clippers and clampers. Please go through the Zener diodes well. I'll quickly revise Zener diodes as well, don't worry. Just give me a couple of minutes. Once we finish this, I'll do Zener diodes also. Yes, once you finish writing this, please let me know.
Yes, sir. Done.
Okay, thank you. All right, now another problem. Yeah, this is a problem. Problem number 3. Now, this is clearly a clamper circuit. Why clamper? Capacitor, resistor, diode together, 101% it is a clamper circuit. What does a clamper do? It takes the wafer, shifts it up, shifts it down. Means it shifts it to a new DC level. Clamper हमेशा waveform को ऊपर या नीचे ले जाता है. As I told you before, very good example of clamper is the X position and Y position on your CRO. You remember that Y position? Whatever waveform you have, you can just take it up, take it down. That Y position does not change your wave at all. Okay, it does not change your wave. Similarly, a clamper cannot change your waveform. It cannot modify it. It can just shift it. So in every clamper problem, one thing you can immediately do is find the peak to peak voltage. What is the peak to peak voltage over here? 10 minus of minus 20, that is 30 volts. Okay. So your peak to peak of your output should also be 30 volts. All right. So see 35 minus 5, 30. This can be the answer. 25 minus of minus 5. This also can be the answer. And 15 minus of minus 15. This also can be the answer. Okay. Usually when you use this condition of peak to peak, one of the options gets eliminated. So it's again helpful to remember that a clamper is not going to cut the wave or modify the waveform. It's just going to shift it. It's just going to shift it. ऊपर या नीचे उसको shift करेगा बस. What was the trick for clampers? If you remember, of course, there is a right way to solve it. Analyze the positive half cycle and the negative half cycle. Use KVL. See what is happening to the diode. Is it forward bias? Is it reverse bias? But as I told you, it will take time in exam. Exam में आपको time लग जाएगा. There's no need for that. One simple thing you can do is This is your node. Okay, this is your node. What do we call a node? Where the capacitor, resistor, and diode are connected. Again, check which terminal is connected, P and N. For clippers, if N was connected, we called it a negative clipper. For clamper, what do we do? What do we do for a clamper? We go exactly opposite, right? We go to the exactly opposite thing. So since N is connected, this is a positive clamper. This is a positive clamper. Positive clamper. Now, what do we mean by positive clamper? It is going to shift the waveform up. It has to shift the waveform up, right? It will clamp it up, not down. So now if you look carefully, which of the following options is possible? Like positive as in, where should it go? This is 10, right? It should go above 10. So 15 is also about 10, 25 is also about 10, 35 is also about 10. So again, all three options are possible. Nothing is eliminated so far. Okay. Next, again go clockwise direction and see which voltage you strike first. So the axis that you get, is 5 volts. The axis that you get is 5 volts. So the new DC level as we called it, the new DC level is plus. Why plus? Because of positive clamper, 2 into input voltage. What's the maximum voltage here? 10, right? Maximum voltage is 10. So 2 into 10 plus 2 into 10 plus, oh, sorry, not the maximum input voltage. We should take half of the peak to peak voltage. This is not symmetric, right? Very sorry. This is not symmetric. We should always take half of the input waveform. This is peak to peak is 30. Okay. So peak to peak is 30, half is 15. So 2 into 15. Very sorry for that mistake. 2 into 15 plus whatever voltage you have as the axis. That is 5. So the new DC level is going to be 35 volts. So this will shift the whole thing and clamp it at 35 volts. So now the maximum voltage is 10. In the new clamped waveform, the maximum voltage should be 35, and that is why A is the right answer. Option A is the right one. Okay, is that clear?
Yes, sir.
Yeah. The actual formula, if you remember, I'll just like to remind you what is the actual formula for the new DC level. New DC level is minus or plus, both, plus for a positive clamper, minus for a negative clamper, 2 times VPB by 2. In our formula, we called it V input because we were considering symmetric waveform. So that is one thing I'd like to again tell you. Not the maximum voltage. We should always take VPP by 2, okay? Whatever is our VPP by 2, or rather the whole thing. That plus whatever is the axis that we get, whatever the axis we get, okay? So see, you can analyze the circuit in the right way. You can analyze the circuit in the right way, but it will take you time. So both for clippers and clampers, I would recommend you use the trick. It will help you. It will save your time in the exam. What if the polarity of the voltage is reversed? Abhishek, which voltage are you talking about? 5 volts? Are you asking about 5 volts?
Yes, sir.
Yes, in that case, it will become minus 5. So when you say plus V axis, your V axis will become minus 5, right? If this was minus 5, this would become 30 minus of 5, it would go up to 25. Sorry. Then B would be the right answer. If only this was minus 5, option B would be the right one. Is that clear?
Yes,
Abhishek?
sir.
Okay, okay. Yeah, so quickly try and write this down. So this was a very brief introduction about clippers and clampers, because I think clippers and clampers are very, very easy scoring marks. Okay, so I just very briefly wanted to revise clippers and clampers. Next, I want to do a little bit about diodes and then Zener diodes. We'll move to the other topics. Yeah, have you all finished writing?
Yes.
Okay, thank you. Yeah, next question. Now, this is a question on diodes. So I think what I should do is, before we go to diodes, before we do this problem, very quickly, let me just remind you what we do in diodes, okay? Because many times students have a confusion about what we do in diodes, right? So very quickly, you all, I hope, must have revised electronics this week or something. So you remember what we do for diodes, all right? So first thing for diodes is we have to start with an assumption. There is no way to solve a diode circuit which is complicated. A simple series circuit we can solve, but usually जो circuits आएंगे, they may not be series circuits. So हम एक assumption लेके start करेंगे. Okay, so the way to solve a diode circuit, how to solve diode circuits. Assume that diode is forward biased. Assume that diode is forward biased. Okay, can you assume it's reverse biased? Yes, but better just assume something. We have what we have done in the classes. We consistently assumed it is forward biased. You could also assume it is reverse biased, nothing wrong. And then find the current flowing through the diode. Find the current flowing through the diode. Now you may flowing through the diode. if current if current is from P to N, if current is from P to N, then diode is forward biased. Diode is forward biased. If current is from if current is from N to P, our assumption was wrong and diode is reverse biased. So what we will have to do, we'll have to go back, change our assumption, and then solve it. Now the thing is, once that you assume the diode is forward biased, how do you replace the diode with? What do you replace the diode with? So you remember the diode models, right? If you have an ideal diode, if you have an ideal diode is replaced with a short circuit. Ideal diode is replaced with a short circuit. Okay. If you have a non-ideal diode, if you have a non-ideal diode, so we will replace it with the cut-in voltage or the threshold voltage. If nothing is given, we will always assume it is a silicon diode and take it to be 0.7 volts. Okay, this is called a non-ideal diode. And finally, by chance, your diode is a practical diode, which is very, very, very rare. I have never seen a question like this. If your diode is a practical diode, what will you do? You will replace it with the cut-in voltage, whatever cut-in voltage is given, V gamma. Okay, I'll write it here. You can also use V gamma if something else is given. If nothing is given, take 0.7 V gamma and a very small resistance which is called the forward resistance. Now this RF has no standard value, okay? RF does not have a standard value. So you will not use this unless and until they specify it in the question. How do you know it is a practical diode? They'll tell you that the diode has a cut-in voltage of this volts and a forward resistance of this ohms. जब तक कि सवाल में वो मेंशन नहीं करते फॉरवर्ड रेजिस्टेंस को, डू नॉट consider forward resistance at all because this is not a standard value. This is something that the manufacturer gives you. ये आपको पता नहीं होता है. कट इन वोल्टेज सिलिकॉन के लिए 0.7, जर्मेनियम के लिए 0.3 आपको पता है. You don't know forward resistance. No one knows forward resistance. Okay. Now, I hope all of you remember what was diode models. Okay. Now, let's do this problem. Okay, I'll just go to the next page. Get some more space to solve this. Yeah. Now this is your problem. In the circuit shown below, D1 and D2 are diodes. The current I1 and I2 are. Okay. Now the first thing to do is to start by making an assumption. Assume that both are forward biased and go forward. But as I told you in the exam, read the question, see the diagram, read the options. That will help you a lot. Okay. If you read the first option, it is 0 and 4. 0 means D1 is off. B is 4 and 0. 0 means D2 is off. C is again 0. D has 1 0. That means 101% either D1 or D2 is off, right? D1 or D2 has to be off. Both cannot be on. Okay. How did I get this? From the options. If you don't get this from the options, just assume both are on. You'll still get the right answer. Okay. But since I saw the options, what I'll do is assume D1 is on and D2 is off. D2 is off. Okay. If I assume this, I have to replace D1 with a short circuit and D2 I have to replace with an open circuit. Now let me redraw the diagram. The diagram will look something like this. This is the first case I'm assuming. The diagram will look, instead of the diode, I'll have a short circuit. And then this resistor, which is 500 ohms. And then this voltage, that is 5 volts. And this voltage, that is again 5 volts. This is connected over here. And now this diode I will replace with an open circuit. So I'm just opening it. Okay. And this is not replaced, sorry. This is given in the circuit that this is 3 volts. Right. Now, okay. Now, if you notice, if you make this assumption, if this is open circuit, then this is not in the circuit, है ना? अगर ये open circuit है, यहाँ current ही नहीं flow होगा, तो ये branch तो आपकी है ही नहीं circuit में. अब ये 5 volt है. If this is 5 volts, as I have told you before, this whole thing is short circuited, right? ये सारे के सारे point short circuited है. अगर ये 0.5 volts है, तो ये point की value क्या होगी? This point voltage at this point will also be 5 volts. Then what will be current flowing in this branch? यहाँ current कितना होगा? This current will be 5 minus 5 upon 500. Current कितना हो गया? 0. Current flowing in this branch is 0. Now that doesn't make sense. If this current is 0, already if D2 is off, मतलब अगर diode 2 मैंने off माना है, यहाँ तो current नहीं flow हो रहा, यहाँ भी current नहीं flow हो रहा, है ना? None of the options are matching. That means my assumption is wrong. Therefore, my assumption is wrong. मैंने जो assume किया था वो गलत था. Assumption is wrong. Is this clear how I got to this inference? ये conclusion तक कैसे पहुंचे, ये clear है? Yes.
Yes, sir.
Others also?
Yes, sir.
Okay. Now, ये assumption तो गलत हो गया. Let us take the second assumption. Second assumption में क्या लूँगा? Now I am going to assume D1 is off. D1 is off and D2 is on. D2 is on. अब इस assumption को लेकर चलते हैं और देखते हैं क्या होता है. Let's take this assumption and see what will happen. So now I again redraw the circuit. Okay, what will we do? Instead of the first diode will be open circuited and second diode will be short circuited. यहाँ short circuit हो जाएगा. Then this is not a part of the circuit anymore. अब इस branch में current कितना है मैं find out करता हूँ. What will be the current in the whole circuit? ये circuit का current यहाँ flow होगा ऐसे. Okay, this will be the current I. What will be the value of current? 5 minus 3 upon 500. यहाँ 5 volts है, यहाँ 3 volts है, ये पूरा का पूरा एक नोड है. This is 3 volts. So 5 minus 3 upon 500. This is 2 upon 500. 5 minus 3 by 500 is how much? 4 milliamperes. 4 milliamperes. This current is flowing in this direction. Where was the diode originally? Originally diode ऐसा था. So is the current flowing from P to N? Yes. If the current is flowing from P to N, my assumption is right. जहां P था, जहां N था, P से N में current जा रहा है, मेरा assumption सही है. My assumption is right. Is that clear? So my assumption is right. In the second diode, current should be 4 milliamperes. In the first diode, current should be 0 milliamperes. So finally I can write I1 is equal to 0 milliamperes and I2 is equal to 4 milliamperes. And so option A is the right one. Option A will be the right option. Is that clear to everyone?
Yes, sir.
Others also?
Yes, sir.
Yes, sir.
Yeah. So always remember, with a diode question, you always have to start with an assumption, unless and until they mention something clearly. Okay. In a diode question, you have to assume. That is why I chose this question, to remind you that you need to make an assumption. Okay, you need to make an assumption. So assume diode is either forward biased or reverse biased, something, and then proceed. Usually prefer forward biased, becomes easier to check, but again, it's just a matter of preference. Like even with reverse bias, you can check equally correctly. Nothing will go wrong. but usually start with assuming forward biased. Okay, so tomorrow, not tomorrow, I mean whenever your paper is, I think third is your paper, right? So if your paper is on third, if there's a diode question, don't panic. See, I think when it comes to diodes, BJTs and op-amps, students somehow get more confused in diodes than in BJTs and op-amps. BJTs and op-amps are much more straightforward. Okay, diodes is where I find students usually struggle. So that's why I'm taking more questions on diodes, because, and again, you don't have to think a lot. Just go through your short notes. I hope all of you have prepared your short notes by now. Just go through the diode models. PN junction diode में क्या करेंगे, Zener diode में क्या करेंगे, Clippers campus में क्या करेंगे. You solve it with a cool head, you'll be able to do it. I am not saying that 101% whatever I have taught, your question paper will only be from that. I would be a fool if I claim that. Okay, मैंने पहले भी बोला है, every single time there is a possibility that they ask you something that is not taught to you, but that is an exception. By and large, you will find questions that you know how to solve them. Only thing is, you're not being able to strike it. So that's why when you look at a question, don't just let your thoughts run wild. Think of which portion this is from. Is this from a diode? Okay. Is this a Zener diode question? Is this a diode question? Is this a clipper clamper question? Then go to that section of your memory and do it. So as I have told you before, if you memorize in a structured manner, you remember in a structured manner. Okay, so it's good to have short notes and memorize, and not even memorize, practice in that way and recollect in that way. I'm sorry for my voice, but this is the maximum volume I can speak at. My I am speaking at a louder volume inside, but this is the maximum volume that comes out of my mouth.
Sir, done.
And okay, thank you. Now we'll do a very, very good question from this year's JAM exam, which was a question on Zener diodes. I thought this was a really, really good question. I mean, I'm not saying it's very difficult or something, but it points to a very what do you say? As I said, if students forget what is the basic thing we have to do once you see a circuit, you might end up making a mistake over here. Okay, so that's why I want to solve this circuit. This is from the JAM exam that happened like 3 weeks back, just before the gate exam. No, 2 weeks before the gate exam. This year's JAM exam. For a Zener diode as shown in the circuit diagram below, the Zener voltage VZ is 3.7 volts. Very straightforward. For a load resistance of 1 kilo ohm, load is 1 kilo ohm. This is given as 1 kilo ohm. A current I1 flows through the load. Okay, if RL is 1K, then the current flowing it is I1. Next, if this is decreased to 500 ohms, if you decrease the load resistance to 500 ohm, current changes to I2. The question is simply find the ratio I2 upon I1. Question is find the ratio I2 upon I1. Okay, very straightforward question, very simple question, but I think it's a good question to test your basics. So again, before I solve this question, what do we do in a Zener diode? In a PN junction diode, we always assume that okay, I'll just scroll up one minute. Let me write down what we do for a Zener diode. This is important. As I told you earlier, there are more questions on Zener diode compared to normal diodes. Okay, so suppose you have a Zener diode in your exam. Any Zener diode question, whether it is the standard voltage regulator circuit or a simple circuit like the one we are solving right now, every Zener diode, first thing we will assume is it is in reverse breakdown. We will assume it is in reverse breakdown. If the Zener diode is in reverse breakdown, what do we replace it with? We replace it with a voltage source, or rather a voltage, the Zener voltage. N is replaced by positive terminal and P is replaced by negative terminal. This is plus, this is minus. What is the voltage that you should use for your Zener voltage? This Zener voltage is again something that will always be mentioned in the question. They will never there will never be a question where this is not mentioned, okay? Because this is a device property which changes. This is not a standard value. So they will mention this value. Now this is the assumption. We assume that Zener is in reverse breakdown. सबसे पहले तो हमने assume कर लिया कि हमारा Zener reverse breakdown में था. अगर Zener reverse breakdown में था तो उसको किससे replace करते हैं? एक voltage से replace करते हैं, वो भी ठीक है. How do you check? How do you check whether what you are doing is like whether your assumption is right or wrong? So at the end, you should always try and find the current flowing. Current flowing. Okay. If current in Zener, if current flows from N to P, exactly opposite to what happened in a PN junction diagram. PN junction की ये बिल्कुल उल्टा है, सीधा मतलब clearly it is opposite to PN junction. If current flows from N to P, then Zener is in reverse breakdown. Reverse breakdown. Okay. Second, if current flows from P to N, if current flows from P to N, then Zener is not in reverse breakdown, but it will still be in reverse bias region. Not Zener is in, Zener is reverse biased. Zener is reverse biased. And I think this is where many students make a mistake that अगर Zener reverse breakdown में नहीं है, तो Zener forward bias नहीं है. Zener will always be connected in such a way that positive is connected to N type, negative is connected to P type. So Zener is always either reverse biased or reverse breakdown. So ये मत भूलना. And always check this. अगर आपने ये check किया उसके बाद ही you assume that whatever you have solved is correct. Otherwise your assumption is wrong. You have to change your assumption. अगर Zener, this is in reverse breakdown. This is in reverse breakdown. What happens in reverse bias region? In reverse bias region, you replace the Zener with a open circuit. Open circuit. ये कब करोगे आप? Reverse, if it is reverse biased. If it is reverse biased. Okay. So I hope you remember this. Okay. Zener के questions में ये बहुत important है. So I hope you all remember this. Is this clear to everyone? ये याद है सबको?
Yes, sir.
इसमें डाउट नहीं है ना किसी को?
No, sir.
Okay. Now let's come to the question. Okay, I'll just take this question down 1 minute. All right. Now let's solve it. For a load resistance of 1 kilo ohm, a current I1 flows, and if it is decreased 500, find I2 upon I1. All right. Let's start by solving. Assume Zener is in reverse breakdown. This is the first case. Zener is in reverse breakdown. I'm just writing RBD for short. Okay. Reverse breakdown. अगर Zener reverse breakdown में है, we will replace it with, किससे replace करेंगे? एक voltage source से. What is the voltage value? 3.7. 3.7. Why? That is the Zener value. Okay. If this is 3.7, तो ये node कितना हो गया? 3.7 volts. In the first case, this node has become 3.7 volts. All right. Now let us solve the whole circuit. ये current कितना हो जाएगा? What will be this current? IS. ये 10 volts है, ये 3.7 है, ये 1K है. So 10 minus 3.7 upon 1K. What is 10 minus 3.7 upon 1K? It should be 6.3 milliamps. Yes, very good. So IS source current is 6.3 milliamps. 6.3 milliamps. ठीक है? First thing हमने find out कर लिया. अब ये 3.7 था, तो ये भी 3.7 है ना? These two are the same thing. ये एक ही नोड है. ये 3.7, तो ये भी 3.7, और ये ग्राउंड है. Obviously this is grounded. तो यहाँ का करंट कितना है? What is this current flowing through the load resistance? See, when RL is 1K, load current is called I1. So I'm writing I1. I1 is equal to 3.7 minus 0 upon 1K. ये कितना हो जाएगा? 3.7 milliamps. Zener current कितना होगा? What will be the Zener current? See, अगर आप यहाँ KCL लगाओगे, if you apply KCL over here, what will you get? IS is equal to, ये IS कहाँ फ्लो हो रहा है? IS यहाँ से आ रहा है, IZ नीचे जा रहा है, और IL यहाँ जा रहा है, तो IS इज इक्वल टू IZ प्लस I1। इससे I1 क्या हो जाएगा, I1 वैल्यू सॉरी IZ क्या हो जाएगा, IZ will be IS minus I1। तो 6.3 minus 3.7 कितना आएगा, 6.3 minus 3.7 2.6 milliamperes। IZ will be 2.6 milliamperes। okay, यहाँ तक याद है सबको, this is 2.6 milliamperes। now if your IZ is 2.6 milliamperes, is the current flowing in this direction from N to P? Yes, current is flowing from N to P, therefore my assumption is right, therefore my assumption is right। अब क्योंकि मेरा assumption सही है, जो भी मैंने कैलकुलेट किया वो भी सही है। okay, because my assumption is right, I can say that yes, I1 is equal to I1 is equal to 3.7 मिली एम्पियर्स। अगर नहीं तो मेरा आंसर गलत होता, इसलिए ऑलवेज चेक वेदर द जीनर करंट इज फ्रॉम N to P या P to N। ठीक है, दिस वाज द फर्स्ट पार्ट ऑफ द क्वेश्चन। नाउ लेट अस सॉल्व द सेकंड पार्ट ऑफ द क्वेश्चन। सेकंड में वी विल अज्यूम now RL is changed। okay, again assume that zener is in reverse breakdown, again assume that zener is in reverse breakdown, zener is in reverse breakdown। okay, now what will happen, IS will again be same, जीनर तो सेम है 3.7, तो IS की वैल्यू वही आ जाएगी वापस 6.3 मिली एम्पियर्स। सेकेंड केस में भी इसको 3.7 ही मानना पड़ेगा, है ना, दिस इज जस्ट 3.7 वोल्ट्स। तो ये 3.7 हो गया, ये 10 माइनस 3.7 अपॉन 1 की सेम लॉजिक जो फर्स्ट केस में यूज किया, सेम लॉजिक, नथिंग चेंजेस। IS इज सेम 6.3 मिली एम्पियर्स। नाउ लेट अस फाइंड आउट which is something which is more interesting, and that is IL, or yeah, or other, in other words we can say I2। if we try and find out I2 की क्या वैल्यू होगी, now this is still 3.7, this is still 0, so this should become 3.7 minus 0 upon 500 ohms। so I'll just write this as 0.5 K because I want the answer in milliamperes। and now if you calculate this will turn out to be how much, 7.4 million,
7.4 milliampere।
thanks, 7.4 milliamperes। ये कितना हो जाएगा, 7.4 मिली एम्पियर्स। ओके, I1 3.7 है, I2 7.4 है, I2 is 7.4, but clearly you see something is wrong। why, सोर्स करंट से आ रहा है 6.3, यहाँ 7.4 कैसे हो सकता है। इफ अगर यहाँ से इतना पानी बह रहा है, अचानक आगे जाके पानी बढ़ नहीं सकता ना, what is happening। सेकंड केस में क्या हो रहा है, इन द सेकंड केस इफ यू कैलकुलेट द जीनर करंट, IZ कितना हो जाएगा, 6.3 माइनस 7.4, जीनर करंट कितना आएगा आपका, 6.3 माइनस 7.4 1.1, राइट, 1.1 मिली एम्पियर्स बट विद अ माइनस साइन। इसका मतलब सेकंड केस में जीनर करंट ऊपर फ्लो हो रहा है, इन द सेकंड केस जीनर करंट इज फ्लोइंग इन द अपवर्ड डायरेक्शन। अब ये तो गड़बड़ है, राइट, दिस इज रॉन्ग। if current flows from P to N, then your zener is not in reverse breakdown, आपका zener reverse breakdown में नहीं है, therefore our assumption is wrong, therefore our assumption is wrong। ये सबको समझ आ रहा है, is this clear to everyone?
Yes, sir. Yes.
okay, so now whatever you are doing, अगर आपने यहाँ I2 निकाला है तो ये गलत वैल्यू है, and actually if you calculate this is 7.4, ये 7.4 upon 3.7 करोगे वैल्यू 2 आ जाएगा, you write 2 over here and you will get a wrong answer, that is what they are expecting। so always calculate zener current। हर केस में उन्होंने क्या पूछा है, that is secondary, what they ask you is secondary, calculate zener current। zener current अगर N to P flow हो रहा है, your assumption is right, whatever you have calculated is correct। if it is not flowing in that direction, your assumption is wrong, whatever you have calculated is with a wrong assumption, obviously it is a wrong answer। okay, all right, now how do we solve this, if our assumption is wrong, now what is the right assumption, right assumption is therefore I'll take a different color now therefore zener is रिवर्स बाइस्ड। अब वो केवल रिवर्स बाइस्ड है, रिवर्स ब्रेकडाउन नहीं है, रिवर्स बाइस्ड। रिवर्स बाइस्ड में रीड्रॉ द सर्किट, इफ आई रीड्रॉ द सर्किट व्हाट विल हैपन, सर्किट को अगर मैं वापस ड्रॉ करूं तो कैसे होगा, हाउ विल द सर्किट लुक लाइक, 10 वोल्ट का सोर्स था, उसके बाद सोर्स रेजिस्टेंस 1K था। जीनर तो ओपन ओपन सर्किट हो गया, जीनर इज ओपन सर्किटेड। और लोड रेजिस्टेंस 500 ohms का है, लोड रेजिस्टेंस इज 500 ohms. Now if you see this is a series circuit, ये तो सीधा सीधा सीरीज सर्किट हो गया, यहाँ तो कोई करंट नहीं फ्लो होगा. सो कैन यू फाइंड आउट द करंट थ्रू दिस? यस, करंट इज वेरी इजी. करंट क्या हो जाएगा? 10 अपॉन टोटल रेजिस्टेंस कितना है, 1K प्लस पॉइंट 0.5K, 1.5K हो जाएगा. 10 बाय 1.5 कितना होगा? 6.66 milliamperes. So now the current flowing through this resistance, that is I2, is 6.66 and not 7.4. Is that clear to everyone?
Yes, sir.
Okay. Okay. Now you can find out the ratio. I2 upon I1 will be 6.66 upon हमारा first value कितना आया था? IS का 3.7. You just calculate and later let me know what is the answer. Okay. Please write it down. Anyone who has a doubt, please ask me. But write it down. खुद से लिखोगे तभी समझ आएगा कि आपको क्या नहीं समझा है. Then you can ask me. Don't just watch it as some video. Write it down. 1.8. Ah, yes, Priyanka, you're right. Very good. 1.8 is the right answer. Yeah, please write the whole thing. Solve it on your own. Rather, just copy करने के बजाय खुद से पूरा solve कीजिए. कहीं मिस्टेक है, नहीं समझ आ रहा है, मुझसे पूछिए. Ask me. So this is all about Zener diodes. Zener diodes का जो last type of question होता है voltage regulator, वो भी मैंने आपको बताया है. How you solve it? Don't memorize the formula. Simple common sense use करना. KCL को याद रखना. IS is equal to IZ plus I. वो भी memorize नहीं करना है, दिखता है. KCL is visible. यहाँ से करंट IS आ रहा है, नीचे IZ और IL बाहर जा रहा है, तो IS is equal to IZ plus IL. One thing will be variable. या तो इसको वेरिएबल कर देते हैं, या तो इसको करेंगे, या तो इसको करेंगे. जो वेरिएबल है उसके दो वैल्यूज फाइंड आउट कर लो, मिनिमम और मैक्सिमम. गो थ्रू योर नोट्स, ऑल द पीवाईक्यूज, ऑलमोस्ट लगभग लगभग सारे के सारे पीवाईक्यूज आपके नोट्स में होंगे. एक बार आपके नोट्स अच्छे से देखिए, स्पेशली द पीवाईक्यूज, एंड डू योर शॉर्ट नोट्स वेल. पीवाईक्यूज आई थिंक आपने अब तक प्रैक्टिस कर लिए होंगे. जो लास्ट के 2-3 दिन बचेंगे, इसमें शॉर्ट नोट्स अच्छे से रिवाइज करना, सब सब्जेक्ट्स के, सिर्फ इलेक्ट्रॉनिक्स की बात नहीं है. और इलेक्ट्रॉनिक्स में वन मोर सजेशन दैट आई गिव यू. ओके, आई लेट यू, आई से दैट एट द एंड. Don't panic. I know it's easy to say here. During the exam, we all panic to some degree, but the best way to solve a paper is with a cool mind. जितना आप डरे हुए हो, जितना आप पैनिक में हो, आप अच्छे से सॉल्व नहीं कर पाओ. अच्छा, if you want me to scroll down, let me know. I'll just scroll up a bit.
Sir, done.
Done? Okay. ये नीचे का भी लिख लेना है तो लिख लीजिए. Okay, all of you have finished writing this. Someone else also confirm?
Yes, sir.
Yes, sir.
Okay, fine. Now, this is another question on transistors, which was a question in this year's TIFR. I think जो दिसंबर में TIFR हुआ था उसमें ये आया था. So this one we have not solved in class. It's a good question. Quite a good question, I thought. Very, very good. I have not taken a screenshot of the options, but anyways, I'll एक ही ऑप्शन हमारे आंसर से मैच करेगा. That will be the right one. Okay. So we don't have to worry, but I'll still, do I have the question? Yeah, I have the options. I'll let you know in some time. All right. Now, see, one is this was a PYQ that was left. So I am taking this question. That is one reason. But second reason is, हाँ, दूसरा रीजन ये भी है कि we have not solved such a question in the class. ना हमने ट्रांजिस्टर के कई सवाल किए, ऐसा सवाल हमने नहीं किया, है ना. ऐसा सवाल हमने किया नहीं. क्यों? क्योंकि एलईडी और ट्रांजिस्टर्स को हमने मिक्स नहीं किया. We did not mix an LED and a transistor. So I am just trying to tell you कि एग्जाम में दिमाग कैसे चलता है. एलईडी पर तो सवाल ही नहीं किया था, एलईडी पे नहीं किया तो सॉल्व कैसे करेंगे. सो ऑब्वियसली आई कैनॉट सॉल्व दिस. डोंट हैव दिस एटीट्यूड. whatever we have solved, as I told you, I am not claiming कि एक बार मैं आपको इलेक्ट्रॉनिक्स पढ़ा दूं, हर सवाल जो मैं पढ़ा रहा हूँ उसी में से आएगा. ऐसा नहीं होगा. उसके बाहर से भी आ सकता है. ओके, 100% आएगा. एक कोई सवाल बाहर से आ सकता है. What I'm saying is we have studied enough electronics to be able to solve many questions, not all, but many questions. Now, if you read this question and if you see, actually we can solve this question. इसमें ज़्यादा कोई बड़ी बात नहीं है. कोशिश करते हैं. Okay. Sorry. Let's try solving this. Consider the collector emitter characteristics of a silicon NPN transistor in the figure below. सबसे पहले तो उन्होंने क्या किया है, कोई भी इंफॉर्मेशन देने से पहले उन्होंने कहा कि हमने आपको आउटपुट कैरेक्टरिस्टिक्स दिए. ऑब्वियसली दीज आर आउटपुट कैरेक्टरिस्टिक्स. कलेक्टर एमिटर मतलब बेसिकली आउटपुट कैरेक्टरिस्टिक्स है. ग्राफ के नेचर से भी पता चलता है. इनपुट का डायोड जैसा होता है, आउटपुट इज दीज काइंड्स ऑफ लाइंस दैट यू हैव. ओके, दीज आर द आउटपुट कैरेक्टरिस्टिक्स. नाउ the circuit on the right is for lighting an LED with an input voltage Vin is equal to 1 volts. First thing what I'm going to do is I'm going to write down whatever they have told us. ये 1 volts. The LED needs 20 milliampere current. इस LED को जलने के लिए कितना करंट चाहिए? 20 milliampere. This current will be provided by the transistor. The LED needs 20 milliampere current that will be provided by the transistor. इसका क्या मतलब है? ये ट्रांजिस्टर इस एलईडी को 20 मिली एम्पियर करंट प्रोवाइड करने वाला है. वेदर इट इज अ एलईडी और इट इज अ पीएन जंक्शन डायोड, एवरी डायोड वर्क्स इन फॉरवर्ड बायस ओनली अपार्ट फ्रॉम जीनर डायोड्स. एलईडी भी तो फॉरवर्ड बायस में ही काम करेगा. मतलब अगर ये फॉरवर्ड बायस होना है तो करंट पी टू एन ही फ्लो होना चाहिए. करेक्ट ना? करंट फ्लो फ्रॉम पी टू एन. व्हाट दे आर सेइंग इज this current will be provided by the transistor. The value of this current is 20 milliamperes. एलईडी में से फ्लो होने वाला करंट 20 मिली एम्पियर का है. एलईडी में से 20 मिली एम्पियर का करंट फ्लो होगा. वेरी गुड. नाउ व्हाट इज द, इस करंट को दूसरा कोई नाम है हमारे पास ट्रांजिस्टर्स में?
आईसी सर.
आईसी. वेरी गुड. व्हाई? कलेक्टर में फ्लो होने वाला करंट आईसी. इनफैक्ट अगर आपको याद होगा, मैंने आपको हमेशा बोला था कि पहले करंट्स मार्क कर लो. ये आईसी होगा, बेस में जाने वाला करंट बेस करंट, एमिटर से बाहर निकलने वाला एमिटर करंट. एमिटर को कैसे पहचानते हैं? विद द एरो. बेस इज अ वर्टिकल लाइन एंड व्हिचएवर इज द लेफ्ट टर्मिनल, दैट जो बच जाता है वो कलेक्टर है. दिस इज द कलेक्टर करंट. सो फर्स्ट इंफॉर्मेशन आई हैव गॉट इज IC is equal to 20 milliamperes. वेरी गुड. आई थिंक आई हैव मेड अ गुड स्टार्ट टू द प्रॉब्लम. मतलब I think I am making some progress. Anyways, let's see whether our progress is helpful or not. A forward biased silicon PN junction has a 0.7 voltage drop across it. अब ये वैल्यू देने की कोई मतलब, basically they, even if they don't give you, no problem. What does this mean basically? This means that the voltage drop here is going to be 0.7. ये voltage drop 0.7 होने वाला है. हाँ, इस डायोड के अक्रॉस भी कोई वोल्टेज ड्रॉप होगा, बट वी डोंट नीड इट क्योंकि हमको करंट पता चल गया ना. we already found out the current, so now we don't need the voltage across the diode. And anyways, now what is the closest value of resistor RB? This is the unknown thing needed for this purpose. इस चीज के लिए RB की वैल्यू अब मुझे बताओ. If we want to find out RB, we need to apply input KVL. And KVL ऐसी चीज है जो हमने कई 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 बार की है. सिंपली KVL कैसे लगाते हैं? इनपुट KVL लगा दो. इनपुट KVL क्या होगा? यहां से आते वक्त -VN प्लस IBRB प्लस 0.7 इज इक्वल टू 0, क्योंकि ये VN विथ रिस्पेक्ट टू ग्राउंड है ना. दिस VN इज 1 वोल्ट विथ रिस्पेक्ट टू ग्राउंड. ग्राउंड से ग्राउंड KVL लगता है. यहां से शुरू किया तो माइनस, फिर प्लस और प्लस 0.7. अब इसमें से मुझे क्या क्या पता है? आई नो VN, आई नो 0.7, आई डोंट नो IB. अब हम लोग वापस आकर अटक गए. वी थॉट वी वर क्लोज टू द आंसर, बट द फैक्ट ऑफ द मैटर इज हमको बेस करंट नहीं पता है ना. बेस करंट हमें क्या है? वी डोंट नो. एनी आइडिया, एनी गेस बेस करंट कैसे कैलकुलेट करें? कोई गेस है?
रिलेशन एक होता है आई इक्वल टू आई बी प्लस आई सी, क्योंकि बीटा तो दिया नहीं है, तो सेकंड वाला वो
पर
क्रिएट
IE
लगा के फॉर आउटपुट।
नहीं, हमें IE भी तो नहीं पता. IE भी तो नहीं पता. IB नहीं पता. IE नहीं पता.
बट सर अगर आउटपुट लगा देंगे तो आई को हम आईसी के टर्म्स में निकाल सकते हैं ना, आई हमको पता है, आई भी वहां से आ जाएगा।
अगर आउटपुट KVL लगाओगे, यहाँ एक वोल्टेज ड्रॉप होगा VCE. ये वोल्टेज ड्रॉप भी हमको नहीं पता. वापस दो अननोन्स हो जाएंगे. सी, डायोड के अक्रॉस का वोल्टेज ड्रॉप भी तो हमको नहीं पता. ये भी एक अननोन है ना. We don't know the voltage drop across diode. We cannot just write -10. See, usually हर problem में there is a resistor over here, है ना. Every problem there is a resistor over here. तो हम लोग IC RC लगा लेते हैं. अगर resistor होता, उसकी value पता होती, तो we could solve what you are saying is right. We could do it. Theoretically we could do it. Okay. Anyone else? कैसे solve करें इसको? बड़ा इंटरेस्टिंग सवाल है. As I told you, TIFR usually asks good questions, but उनका इलेक्ट्रॉनिक्स का भी लेवल ऐसा बहुत कोई बड़ा नहीं है कि हम लोग सॉल्व नहीं कर पाएंगे. इजी सवाल है. थोड़ा सा बस उसको यहाँ वहां घुमा देते हैं और कुछ नहीं. ओके, लुक एट द फर्स्ट लाइन. ऑलवेज चेक द क्वेश्चन अगेन एंड अगेन. आपके पास सी, ये कई बार मुझे लगता है, आई डोंट नो आपने कभी मास्टर शेफ देखा है या नहीं. ये इलेक्ट्रॉनिक्स का जो इलेक्ट्रॉनिक्स ये जो कॉम्पिटिटिव एग्जाम्स के सवाल है ना, दिस इज जस्ट लाइक अ मास्टर शेफ एपिसोड. यू दे जस्ट गिव यू अ बॉक्स सेइंग इसमें इतने इंग्रेडिएंट्स है, इसके साथ कुछ बना दो. दैट इज ऑल दैट यू हैव. सो when you don't know what to do, just go back to your ingredients box and search कि इसमें कुछ दिया है, उसमें कुछ और तो नहीं दिया, कुछ और तो नहीं दिया. अच्छा, इसका क्या यूज हो सकता है? ये सब्जी क्यों दी थी? Why do I use this vegetable here? So just think of this is your information. Go back and read it again. We have used all the information except the first line. First line क्या था? Consider the characteristics that are shown below. Characteristics पे ध्यान देते हैं. Characteristics को अगर आप ध्यान से देखोगे तो characteristics, by the way, ये डायग्राम क्लियर है? ये ग्राफ दिख रही है सबको? Is this visible to everyone?
Yes, sir.
Okay. अगर ये विजिबल है, आपको क्या दिख रहा है? बेस करंट जब 200 माइक्रो एम्पियर है, आपको आउटपुट कैरेक्टरिस्टिक्स का ग्राफ याद है? डू यू रिमेंबर द ग्राफ ऑफ द आउटपुट कैरेक्टरिस्टिक्स? वी ड्रॉ डिफरेंट कर्व्स, राइट? हम अलग अलग कर्व्स ड्रॉ करते हैं. एक IB के फर्स्ट वैल्यू के लिए, सेकंड वैल्यू के लिए, थर्ड वैल्यू के लिए, और हम मार्क क्या करते हैं उस पर? वी मार्क द कलेक्टर करंट्स. IC को मार्क किया जाता है, IC3, IC2. अगर आप देखोगे यहां बिल्कुल वही बात उन्होंने की है. दे हैव डन द सेम थिंग ओवर हियर. सो लेट्स लुक एट टू कर्व्स, है ना. मैं नीचे वाला कर्व देख रहा हूं क्योंकि वो मुझे ज्यादा लीनियर नहीं, मतलब ज्यादा पैरेलल लग रहा है एक्स एक्सिस के कंपैरिजन में. बेस करंट जब 200 माइक्रो एम्पियर था, व्हेन द बेस करंट वाज 200 माइक्रो एम्पियर्स, व्हाट वाज द कलेक्टर करंट? समवेयर ओवर हियर. ये 10 है, ये 20 है, उसके बीच में 5 डिवीजन है. सो दिस इज 12, दिस इज 14. ये 14 हो गया. एंड कलेक्टर करंट इज गिवन इन मिली एम्पियर्स. ये मिली एम्पियर्स में दिया है. दैट मींस when base current is 200 micro, when base current is 200 micro, तो कलेक्टर करंट कितना है? 14 मिली. इससे क्या मैं बीटा निकाल सकता हूं? यस, बीटा की वैल्यू होगी IC अपॉन IB. ये कितना हो जाएगा? 14 अपॉन इसको 0.2 मिली लिख देता हूं ताकि मिली मिली कैंसिल हो जाए। बीटा की क्या वैल्यू आएगी इससे?
70।
70। बीटा की वैल्यू 70 आ गई। नाउ यू माइट से कि अगर यही कोई स्टूडेंट एग्जाम में इसको यूज करता, अगर ऊपर वाले को यूज करता, तो एक तो ये 400 का बहुत ज्यादा पैरेलल नहीं है, ये यहाँ कहीं मीट हो रहा है, सो दिस वुड बिकम ये 30.2 होता ना, 30.2 अपॉन 0.4, इसकी जो वैल्यू आती है वो बाद में निकालो। 70 नहीं आएगा, बट इट विल बी अराउंड 70। ये 70 से बहुत ऊपर नीचे नहीं होगा। ओके, सो आई नो इट इज नॉट 70 एग्जैक्टली 70 तो नहीं है, बट इट इज समवेयर क्लोज, समवेयर क्लोज। सो दिस वन वैल्यू 70 इज गुड इनफ फॉर आवर आंसर, ये हमारे लिए सब पर्याप्त है। अब इनपुट केवीएल लगा लो, इनपुट केवीएल को सॉल्व कर लो। वीएन कितना था? -1। आईबी कितना है? ओ आईबी अभी भी नहीं पता मुझे। आईबी को मैं क्या लिख सकता हूँ? आईसी अपॉन बीटा, है ना, आईसी अपॉन बीटा इंटू आरबी प्लस 0.7 इज इक्वल टू 0, है ना। इससे क्या हो जाएगा? आरबी इज इक्वल टू ये 1 माइनस 0.7 0.3 हो जाएगा। आईसी अपॉन बीटा कितना हो जाएगा? बीटा 70 था, और कलेक्टर करंट कितना दिया था उन्होंने? 20 मिली एम्पियर्स, 20 मिली एम्पियर्स। तो अब इसको सॉल्व करो, ये 0 0 कट हो जाएगा। फाइनली मुझे किलो ओम्स में आंसर बताना।
1.05।
1.05, ओके, 1.05 के। और टीआईएफआर में जो ऑप्शंस थे, आई डोंट हैव द ऑप्शंस रिटन डाउन, बट द फर्स्ट ऑप्शन वाज द वन दैट वाज क्लोजेस्ट, दैट वाज 1.1 के। नाउ यू माइट से कि व्हाई डिडंट वी गेट द एग्जैक्ट आंसर? ये जो डिस्क्रिपेंसी है इसकी वजह से, क्योंकि ये बीटा सिर्फ इस पे नहीं बेस्ड है, ये ग्राफ से हमने बीटा कैलकुलेट किया है ना, ऊपर के वैल्यू के लिए थोड़ा ज्यादा थोड़ा कम आएगा, सो दैट इज वेयर द डिस्क्रिपेंसी इज कमिंग, बट बेसिकली आवर आंसर इज करेक्ट एंड द अदर ऑप्शंस वर नॉट क्लोज। ओके, दूसरे ऑप्शंस देयर वर मच डिस्टेंस, एक 1.5 के था, एक 3.7 के था, एक 4 के, सो देयर वाज अ लॉट ऑफ, द ओनली करेक्ट आंसर इज द फर्स्ट वन which was 1.1 के। Is this question clear to everyone?
Yes, sir.
I thought this was a really, really good question. Last GATE exam there was a very good question on transistors, and this बहुत साल बाद कुछ अच्छे सवाल ट्रांजिस्टर्स पे दो बार उन्होंने पूछे, एक गेट में और एक टीआईएफआर में। गेट का सवाल हमने अपने नोटबुक में किया है, पिछले गेट का क्वेश्चन।
सर एलईडी देकर कंफ्यूज कर दिया।
हाँ, that's all. So, see, most of what is going to happen is they'll just give you some things and we think कि अरे हाँ ये तो मैंने किया ही नहीं, ये तो मुझे आता ही नहीं। Oh, Abhishek has asked a question. This year's GATE paper, there was a question of op-amp where they connected at the Zener diode at the output of the resistance branch. Abhishek, I have not yet got the PDF of the, I checked today also, the response sheet is not yet out. So once someone gets the PDF, please send it to me. I want to look at the GATE paper. I have not been able to see the GATE paper yet. So JAM का response sheet आने के बाद some students send the PDF. Once you get the, if you remember the question, we can solve it now also. If you remember the question exactly, कि op-amp, and I think we had done one question in the class, ना, op-amp and Zener को mix करके. Oh, by the way, if op-amp and Zener is mixed, what will you do? Don't panic. Do the same thing. Assume Zener is in reverse breakdown and solve it. Oh, you don't remember? No problem, no problem. I saw a couple of YouTube videos जहाँ वो memory based questions discuss करते हैं ना, मैंने वो देखा सवाल, but I was waiting for the PDF. Once the PDF comes, we'll release a solution. हम लोग यहाँ Elevate में भी we will release a solution of detailed solution of the problems. JAM exam, that video might come out soon. So this time in JAM exam there were I think 4 questions. 7 marks were quite easy out in electronics. Only one question in transistors, the question I felt was wrong. So if they change it, very good. I think the question itself was wrong. मतलब जो तरीके से वो आंसर एक्सपेक्ट कर रहे हैं, that is not possible. I don't know. Okay, once you finish writing this, please let me know. But this is a really, really good question. If you have a doubt, if you have not understood, please ask me. I'll explain again. कुछ नहीं समझ आया तो वापस एक्सप्लेन करता हूँ.
Sir, done.
Done? Okay. Now, before we go on to op amps, there is something about transistors that I want to just discuss again. Okay. बहुत जल्दी से आपको as a revision, let's take say 5 minutes or something and very quickly go through some parts about some things about a transistor. See, there are three basic configurations. Don't forget that there are three basic configurations of a transistor. What is the first one? First one is the fixed bias configuration. पहला वाला क्या होता है? Fixed bias configuration. Fixed bias configuration में आप क्या करते हो? In the fixed bias configuration, it looks something like this. This is VCC. This is the first kind of configuration. Then you have some resistance over here, that is the base resistance. Some resistance over here, that is the collector resistance. This is your transistor. And there may be a resistance at emitter, there may not be a resistance at emitter. Okay. So as I told you, how do you solve this circuit? We have done all the PYQs on these kinds of problems. Okay. So I'm not solving any problem here. Very easy, but I'll still tell you what to do. आप क्या करोगे? Very simply. First, any transistor question, mark the currents. सबसे पहले क्या करोगे? Currents mark करो. ये current क्या होता है? Base current. This current is the emitter current. This current is the collector current. First thing. And mark two voltages. This voltage is the base emitter voltage. If nothing is given, we will always take this to be 0.7 volts. Don't forget the base emitter the base emitter junction of a transistor behaves as a forward bias PN junction type. Okay, base emitter का जो voltage है, that base emitter junction, junction है, it behaves as a forward bias PN junction type. So always take this as 0.7 unless mentioned otherwise. उन्होंने कुछ mention किया अलग तो ही, नहीं तो यही लेना हमेशा. Second, this voltage VCE. अब क्या करना है? एक बार इनपुट KVL लगाओ, एक बार आउटपुट KVL लगाओ. What is input KVL? इनपुट KVL इस साइड से लगेगा, है ना? इनपुट KVL क्या होगा? लेट मी राइट इट डाउन. इनपुट KVL विल लुक लाइक माइनस VCC प्लस IBRB प्लस VBE प्लस IERE इज इक्वल टू 0. इनपुट KVL लग गया, है ना? एंड व्हाट विल बी आउटपुट KVL? आउटपुट KVL इस साइड पे लगेगा. सो आउटपुट KVL विल बी, आउटपुट KVL होगा माइनस VCC प्लस ICRC ICRC plus VCE plus IERE is equal to 0. is equal to 0. Okay, ये इनपुट KVL हो गया, ये आउटपुट KVL हो गया. डन, वेरी गुड. अब अननोन क्वांटिटीज को सॉल्व करने के लिए और क्या क्या चाहिए हमको? वी नीड दिस रिलेशन बीटा इज इक्वल टू IC अपॉन IB. इफ बीटा इज नॉट गिवन, हम लोग क्या अज्यूम करेंगे? Assume beta is very high. Beta is very high. And in this case, collector current is approximately equal to emitter current. Another relation is IC is equal to beta times IB. ये तो हमको पता है. IE is equal to beta plus 1 times IB. बस इतने relations use कर लो and you can solve any question. कोई भी सवाल हो, इन सब relation से आप solve कर पाओ. Is that clear?
Yes, sir.
ये याद है ना सबको? ओके. सेकंड कॉन्फ़िगरेशन क्या था हमारा? सेकंड इज कलेक्टर टू बेस फीडबैक. कलेक्टर टू बेस फीडबैक इस, अच्छा, एनीवन वांट्स टू राइट दिस डाउन? कोई जरूरत नहीं है ना, ये तो हमने लिखा हुआ है नोटबुक में.
सर VC कैसे कैलकुलेट करेंगे?
सॉरी
VC कैसे कैलकुलेट करेंगे?
सी यू VCC will be given. These other terms you will calculate by input KVL and then these terms. So finally आपको बस VC बच जाएगा. So you can just use this equation to solve it. Okay. So first you will start with input KVL. Input KVL में you will almost 100% times you will get the value of IB. एक बार आपको IB मिल जाता है, आपको IC पता चल जाता है, IE पता चल जाता है अगर बीटा दिया है तो. If beta is given, then everything is known and you calculate VC. So in the exam, sometimes they may ask VC, sometimes they may ask RC, sometimes they may ask RB. जो भी वेरिएशन होगा आप सॉल्व कर लीजिएगा. ओके, ऑलराइट. व्हाट इज द सेकंड टाइप? एंड रिमेंबर फर्स्ट टाइप के ऊपर सवाल आए हैं. द फर्स्ट टाइप देयर हैव बीन क्वेश्चंस इन द पास्ट. हाउएवर सेकंड टाइप इज मोर इंपॉर्टेंट क्योंकि सेकंड टाइप में बच्चे ज्यादा गलतियां करते हैं. सो In fact, if you remember in the PYQ, once even NET had made a mistake in that question. They had marked that as IC, which was wrong. Okay, let me draw the second type, which is collector to base biasing. ये कौन सा होता है? Collector to base biasing. Second वाला type कैसे दिखता है? This is VCC. This is RC. Oh, sorry. VCC, RC, RB, collector, emitter, emitter का resistance and ground. Now what is the mistake that students will make here? मैंने पहले क्या कहा था? हमेशा करंट्स मार्क करना. अंदर जाने वाला करंट बेस करंट, एमिटर से बाहर आने वाला करंट एमिटर करंट. यहां तक तो सब बच्चे सही करेंगे. दिस करंट एवरीवन विल मार्क एज कलेक्टर करंट. नो, दिस इज रॉन्ग. क्यों गलत है? कलेक्टर में जाने वाला करंट कलेक्टर करंट है. ये करंट कलेक्टर नहीं है. ये देखो, ये करंट इज कमिंग एंड देन स्प्लिटिंग इनटू टू. यहाँ आईबी बन रहा है, यहाँ आईसी बन रहा है. सो दिस करंट इज एक्चुअली आईसी प्लस आईबी, और इन अदर वर्ड्स यू कैन राइट दिस करंट इज आईई. ये मिस्टेक मत करना बस. अगर आपने ये मिस्टेक कर ली तो फिर आपने 100% यू आर रॉन्ग. 100% you have made a mistake. ठीक है? So I hope all of you remember this. इसमें the only reason they'll ask you this question is because they know that students will go wrong here. So don't make this mistake. Collector current is the one that enters the collector terminal, not collector resistance. को resistance से पास होने वाला करंट collector current नहीं होता. इसमें डिफरेंस याद रखना इस टाइप में. Now use input KVL, output KVL. अब input KVL क्या हो जाएगा? If you use input KVL will be minus VCC plus IE into RC. क्यों? क्योंकि ये IB plus IC है, which is nothing but IE, plus IB into RB. ये वोल्टेज कितना होता है? This is VB, this voltage is VB plus VB plus IERE plus IERE is equal to 0. Please don't memorize these equations. ये memorize नहीं करना है. The more you memorize, the more you will forget. KVL ही लगाना है. You're strong at network theory, you solve diodes, op amps and BJTs. कुछ है नहीं उसमें. Don't forget that. You don't have to memorize this. Okay. Next, output KVL लगा दो. Output KVL will come straight down. Output KVL क्या होगा? Output KVL will be, अच्छा ये voltage लिख देता हूँ. This is plus VCE. So output KVL will become minus VCC plus IERC plus VCE plus IERE is equal to 0. That's all. ये हो गया आपका solve. Nothing special, but this is one mistake that will happen. That students will end up making this mistake and then you make, मतलब उसमें आपका गलत हो जाएगा. ठीक है? Now the third and final type, again which is very 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 crucial. First से second ज़्यादा important है exam point of view से भी, और second से third बहुत ज़्यादा important है. Okay, there is a higher likelihood of a question coming from the third type than from the second than from the first. What is the third type? Third type is the famous voltage divider bias. Voltage divider. How does this circuit look? It looks something like this. ये resistance R1, this is the collector resistance RC. Collector है मतलब it is connected to the collector. Then this is the emitter, and now this will be connected to the base, and this will be through another resistor. This is grounded. This whole thing is grounded. This is your voltage divider method. Okay, in this case what do? In this case we transform the circuit to something else. Do you remember how we transform it? क्या आपको याद है? First था VTH find out करो. What is VTH? VTH is the Thevenin voltage. You don't need to know Thevenin's theorem or something. It is just voltage divider. यहाँ से बस voltage divider लगाना है. क्यों? क्योंकि अंदर कोई current नहीं flow होता. That is the assumption. Base current is so tiny, microamperes, that this is as good as a voltage divider. So VTH is equal to R2 upon R1 plus R2 into VCC, and second RTH is equal to R1 R2 upon R1 plus R2. So RTH का मतलब क्या है? ये दो रेजिस्टेंसेस as good as are in parallel. Then you change the whole circuit and the new circuit will look something like this. VCC है, RC है, collector है, base emitter, RE and this is grounded. और left hand side को क्या हो जाएगा? One resistor that is RTH and one voltage that is VTH. बस VTH आपने फाइंड आउट कर लिया, RTH आपने फाइंड आउट कर लिया, that's it, that will be your answer. इससे ज्यादा कुछ बचेगा नहीं. Okay, so this is again something that you should remember. VTH और RTH का फॉर्मूला याद रखो. Okay, if you are through with this, then you will be able to solve it in the exam very easily. यहाँ तक clear है सबको? Any doubt so far? Okay, one last thing. Do you remember the formula for power dissipation? Transistor का power dissipation, by chance this is asked. Do you all remember the formula? Power dissipation का formula क्या था transistor के लिए? Yes, anyone? VB dot IB plus VCE dot IC. And I told you that this value is almost never taken. I know, but sometimes this value might be given to you and then you have to take this also. Actually, power dissipation, the formula is only VC into IC. But if you remember the DC model, if you just go through your notes, हमने DC model of BJT किया था. The actual power dissipated is at two places. यहाँ भी power dissipate होगा और यहाँ भी होगा. ये याद रखना. एक बार TIFR में सवाल आया था, हमने नोटबुक में किया है. We have done this question on TIFR, this problem on power dissipation. Remember this formula. Okay, छोटी छोटी चीजें हैं. यहाँ से कुछ आ गया तो you should not get confused. Please remember this. इसको memorize कर लेना इस formula को. या एक बार बस DC model revise कर लो. Another thing is output characteristics में you remember the saturation region. All of you, saturation region याद है सबको output characteristics में? Okay, so this is from the DC load line analysis part. Okay, ये जो हमारा output characteristics का graph है, if you have IC on this axis and VCE on this axis, the graph looks something like this. I'm not explaining the whole thing. I'll very quickly draw it. I mean, anyways, I'm not good at drawing anyways. But if this is your, if these are your curves, है ना, अगर ये आपके curves है transistor के, so of course this should be more neatly drawn, but I have not drawn it. Leave it. इसमें regions क्या होते हैं? This region over here is the cutoff region. यहाँ आपका transistor is not working at all. This region is the cutoff region. Cutoff region. ये याद है ना सबको hopefully. And this region is the active region. ये जो region होगा ये active region होगा. This will be the active region. And finally this region is the saturation region. ये जो यहाँ का region है, this is the saturation region. Saturation region. Now if you draw a load line, अगर आप DC load line draw करते हो, so how does the load line look like? The load line looks something like this. Okay, what is the value here? VCC, 0. मतलब no collector current, maximum collector voltage, maximum voltage, that is VCC. यहाँ current ही नहीं है. We have done a problem on this. Please go and revise this because इसके ऊपर if there are any questions, you should be able to answer them. Okay, I'm just briefly giving you an idea of what is the load line. Then somewhere over here will be the Q point. What is the Q point? Q point is just the value of VC, IC. Bas X, Y coordinate. VC is the output voltage. IC is the output current. है ना? Next, what is the maximum saturation current? Does anyone remember this value? IC saturation का क्या value था? This value is VCC upon RC. Okay, so we have this relation, right? IC is equal to beta times IB. ये कितना एम्पलीफाई करेगा? कर करके कितना एम्पलीफाई करेगा? Unlimited? No. There is a maximum limit for IC. IC maximum is called IC saturation. And what is the IC saturation value? It will be VCC for RC for most transistor configurations. Okay, and I have taught you how to calculate this value also. I mean, you can look at that. If you remember, we had drawn a circuit and we had got this value. Maximum value क्या होगी? VCC by RC. Okay. So if your collector current crosses this value, then your transistor is in saturation. We have done 2 problems on this, I think. These were previous net problems. Please go through them, because if your transistor is in saturation, then this relation is no longer valid. This relation is not valid in the saturation region. Okay. So saturation current use करके you cannot calculate IB. This is the mistake that was made in this year's JAM exam by the paper setters. I believe they had made a mistake. Okay. So yes, any doubts in this output characteristics of a transistor? किसी को doubt है? Anyone has a doubt here?
No, sir.
Okay. We have done this. Okay. Please don't be so silent.
सर
हाँ.
और एक बार प्लीज समझा दीजिए क्यू पॉइंट है क्या, मतलब कैसे हम देखेंगे इसको?
No, no. Q point is nothing but when you solve the circuit, whatever is your DC circuit, जब हम DC circuit को solve करते हैं, जो भी आपको collector current मिलता है IC और जो भी VC मिलता है, if you write it as a coordinate, that is a Q point. That's all. Now, why is it called a Q point? That is a matter for extra theory. उसमें हम नहीं जाएंगे. Basically, it is a quiescent point. Quiescent point. I don't know the exact pronunciation of the word. That means when the transistor is silent. मतलब अगर आपने कोई AC input नहीं दिया है, उस समय आपके ट्रांजिस्टर का क्या आउटपुट है? That is called the Q point. So basically, how do you calculate the Q point? Not from the graph. You solve it by solve the circuit, input KVL, output KVL. You will get the value of VC. You will get the value of IC. That will be your answer for Q point. Is that clear?
Yes, sir.
Okay. Please go through this. Okay. If you have a doubt in this, you can message me. But once go through the notes, we have solved this. Or yeah, please go through your notes once. इसके ऊपर सवाल आते हैं. Anyone has a doubt in this output characteristics? Saturation region में किसी को doubt है? Remember, IC saturation is the maximum value of IC. Okay. All right. So no doubts. आगे जाए. All right. Now let's come to op amps. Op amps में what is the main thing that we have to remember in op amps? Is virtual ground valid? Virtual ground कब valid होता है? Okay, very quickly before we do one simple problem in the recent JEST paper. I think last year के JEST paper, we didn't do it in the notebook. This is just a simple. You have an op amp. This is the non-inverting terminal. This is the inverting terminal. Non-inverting voltage, inverting voltage. This is your output voltage, V0. Okay. What is the virtual ground concept? If you have an op amp, where the output is somehow connected to the inverting terminal. Okay. अगर इस तरीके का path होता है, if there exists a path between the output and the inverting terminal, ये inverting terminal है और यहाँ अगर कोई input voltage दिया है, let's say this is grounded. In this case, this feedback can be given through a resistor, it can be given through a capacitor, it can be given through a diode, it can be given through an inductor, it can be given through a transistor, it can be given through a Zener diode, we don't care. Or it can be directly short circuited, वो भी चल जाएगा. If this is directly short circuited, that is also okay. हम लोग करते हैं ना बफर में, we have done that in a voltage follower, right? Buffer circuit जिसको बोलते हैं, we directly short circuit. So whether it is short circuited or through a resistor, through a capacitor, diode, doesn't matter. If the output is connected to the input through a element, then there is negative feedback. Okay. If there is negative feedback, then op amp is in linear region. If op amp is in linear region, then your virtual ground concept is valid. If there is no negative feedback, then virtual ground concept is not valid. In that case, your op amp behaves as a, anyone remembers? Comparator. अगर op amp को feedback नहीं है और op amp is in saturation, दोनों चीजें हो सकती है. Op amp either is no feedback or op amp is in saturation. In both cases, your op amp behaves as a comparator. Okay, you all. And what is virtual ground concept? Virtual ground concept tells you whatever is the voltage here, the same voltage will appear here. What is the voltage here? 0 volts. So this also will become 0 volts. Okay. And of course, there should be a resistor over here. This will always be true if there is negative feedback. Is that clear? ये याद है सबको? Yes.
Yes, sir.
Okay.
Yes, sir.
Now let's do a problem from this was from last year's JEST exam. Very easy problem. What is the output voltage V0 and current in the 10K? Just give me a minute. I'll just drink some water. Anyone would like to try and answer? Please go ahead and answer in the chat. Don't unmute. Answer in the chat. Yes, anyone has answered in the chat? किसी ने answer किया है? Yeah, one thing I would say is please don't panic before an exam. If you don't suddenly remember something, no problem. You still have 1 week. Go back and look through your short notes, okay? डर मत जाना. Don't be in a panic mode before the exam. Yes, very good. Good. And solve it. Sorry, I needed some rest actually. So that's why I didn't solve it immediately. First of all, every single problem on op-amp can be solved using nodal analysis. बस nodal लगाना है और कुछ नहीं. Nodal लगाओ, get the answer. Apply nodal, get the answer. Apply nodal, get the answer. Network theory, if you're good at network theory, you will solve every op-amp problem. We have solved all the PYQs, almost all PYQ. I think ये एक बच गया था. TIFR में भी कोई PYQ नहीं था दिसंबर के. Otherwise, we have solved every single PYQ on op-amp almost. Okay. So op-amps is again a very scoring topic. Go through it once. Negative feedback है. Op-amp is in linear region. Virtual ground concept is valid. That's all. Let's check. Is the op-amp, is there negative feedback? Output is connected to inverting terminal. That means there is negative feedback. Yes, Sumanto, you're right. Very good. Negative feedback है. Negative feedback मतलब virtual ground concept is valid. What is virtual ground concept? Whatever voltage is here, same voltage will come here. ये तो ground से connected है, तो ये भी 0 हो गया. This is 0 volts. This also will become 0 volts. This is 0. This is also 0. Now simply apply nodal over here. यहाँ nodal लगाओगे तो क्या होगा? 0 minus input upon 10. Input कितना दिया है? 0.5 upon 10 के. Plus यहाँ आओगे तो क्या होगा? 0 minus output upon 25 के is equal to 0. From here, just calculate the output. Output should come out to be minus 1.25 volts. Minus 1.25 volts. Okay. Yes, Pradeep, you're right. Very good. Other way to do it is, this is nothing but an inverting amplifier. Inverting amplifier के लिए we have the formula minus RF upon input into input voltage. वो use कर लो. Feedback resistance कितना है? 25K. यहाँ कितना है? 10K. 25 by 10 multiplied by 0.5. वो भी वही होगा 2.5 into 0.5. That will again give you minus 1.25 volts. Whichever method you use, I told you in op-amp, if you forget anything, no problem, use nodal. कोई भी फॉर्मूला आप भूल जाते हो, नोडल अप्लाई करो, यू विल गेट द आंसर फॉर श्योर. 100% आपको आंसर मिलने वाला है अगर आप नोडल अप्लाई करोगे. ठीक है, ये minus 1.25 volts हो गया. So option A और option D is correct. But the second thing they are asking is current. ये current का है, current I in the 10 kilo ohm resistance. मतलब they want this current. They want this current. How can we calculate this current? The voltage at this point is 0.5. Voltage at this point is 0 volts. Resistor 10K है, तो यहाँ flow होने वाला current कितना होगा? Current will be 0.5 minus 0 upon 10K. मतलब 0.5 upon 10K, that is nothing but 50 microamperes. So option A is the right one. Option A will be the right one. ये problem सबको clear है?
Yes.
Yes. Okay. Write it down. Once you finish writing, let me know. Diagram भी draw कर लेना. So go through the op-amp section. For op-amps, you don't have to worry a lot. Go through your notes, and mostly, even if you don't go through your notes, nodal. If you apply nodal, that is more than sufficient. But once go through your notes, you'll be able to see some different PYQs, and like today we had the revision class. Aaj agar if you very quickly skim through your notes through the problems, you'll be able to solve most of them. I think already you should be able to solve most of them. Remember, we have done adder, subtractor, then logarithmic amplifier, anti-logarithmic amplifier, integrator, differentiator. Again, a lot of questions will come from integrator, differentiator. Okay. When is an op-amp an integrator? When capacitor is in feedback. Capacitor agar feedback में हो, तो op-amp behaves as an integrator. Op-amp will behave as an integrator. Okay. और input में क्या होगा? Resistor. And if this is reversed, if input element is capacitor, then it is a differentiator. Integrator, differentiator, don't forget, that is very, very, very important. Okay, integrator and differentiator are good, important questions that you'll have many, many times in your exams. Okay. And then comparators. We have also solved comparators. Op-amp without feedback or op-amp in saturation behaves as a comparator. Then we also solved op-amps plus diode questions, if you remember. We have that in our notebook. And finally, high pass filters, low pass filters. Okay. Remember high pass and low pass as well. Low pass filters behave as integrators. High pass filters will behave as differentiators. And especially remember the transfer function for both. We have derived the transfer function for low pass filter and for high pass filter. Okay. If you want me to write it very quickly. Have you all finished writing this question for op-amps?
Yes.
Okay. High pass filter का transfer function क्या था? The transfer function for high pass filter was RCS upon 1 plus RCS, right? RCS upon 1 plus RCS. That was for a high pass filter. So was for a high pass filter. Low pass filter के लिए क्या था? Low pass filter के लिए it was just 1 upon 1 plus RCS. For a low pass filter, it was 1 over 1 plus RCS. So just use Laplace. Laplace में कैपेसिटर को हम क्या करते हैं? We represent capacitor with, कैपेसिटर को किससे रिप्लेस करते हैं? 1 by S. Replace it by 1 by S. R is R. And then just treat this as a resistance. 1 upon R, 1 upon S can be treated as a resistance. Find the transfer function. If it is matching this high pass filter, if it is matching this low pass filter. End of story. Okay. High pass filter low pass filter behaves as an integrator. High pass filter will behave as a differentiator. Okay. All right. So please go through op-amps. Again, very, very easy topic. Okay. You should be able to score good marks if you have a question based on op-amps. Now we finally come to digital electronics. This is again a very huge chapter. We are not going through the whole thing, but some important things. Please go through Boolean laws very well. Boolean laws and logic gates. Most often there is one question from this JAM exam that was there. I don't know about gate. I don't have the paper yet. But usually from digital, the first part, Boolean and logic gates, you'll have one question. Okay. So we'll just do one question from this TIFR exam, December exam. Again, I don't think we have solved this in our PYQ, in our notebook, because this was a very recent exam. Now, there's nothing special about this question. Very basic, like बहुत ज़्यादा basic सवाल है. Nothing extravagant. Only reason is why I'm taking this is, if you look at the options, I have not taken a screenshot of the options. I'm sorry. I have 1 minute. No, I don't have the मेरे पास options का screenshot नहीं है, but you still need to check up to 5 digits to get the right answer. That is why this question is interesting. Okay, I'm very sorry, I forgot to take the options, but let us very quickly see how to solve this. The output pulse train Y of the circuit, output pulse train Y of the circuit shown on the right with 3 synchronized input trains. मतलब A में आप continuously you are inputting this. First you will input 0, next cycle 0, next cycle 0, next cycle 0. B में you will input 0, 0, 1, 1, then so on. C में you will input this. And they want the option Y. Answer Y क्या होगा? In इतने decimal places तक they want the, not decimal places, sorry. For all these variables they want the answer. Okay. So how to solve this? Very simple. ये and है, ये and है, ये and है. If any one is 0, output will be 0. Yeah, what is the output? What is the input? A is given and C is given, right? So here you have A dot C. Here you have B dot A, that is A dot B. And here you have B dot C. So C is A 0? Yes. Is B 0? Yes. So the first one, 0 plus 0 plus 0 has to become 0. Okay. Can you just solve up to say 5 तक कोई solve करके मुझे बताएगा 5 values क्या होंगे? First 5 values. Leave the remaining 3. At least can you solve for first 5? How did I solve for the first one? A is 0. So यहाँ AND gate का output 0 आ गया. B is 0. इन दो AND gates का 0 आ गया. 0 plus 0 plus 0 is 1. This is OR gate. This is AND gate. Second, take 0, 0, 1. Then let me know what you get. Anyone can at least solve for a few decimal places, few values. 0, 0, 0, 1, 0. Yes, Abhishek, you're right. Very good. If you have finished this, can you solve further also? Because two options were same till 5 places, till 6. It is the 7th one that was different. Yes, very good. The final answer should be 0, 0, 0, 0, 1, 0, 1, 1, 1. Oh, sorry, 3 zeros, not 4. 3 zeros, then a 1, then 0, then 1, 1, 1. Okay, very straightforward question. Just to remember, just to refresh your memory of logic gates. Please do XOR gates well. De Morgan's laws. De Morgan's laws, remember, if there is a break, join it. If there is a join, break it. Right? Complement operators mein. If you have x dot y complement, what is De Morgan's law? If you have x dot y complement, dot changes to plus, this complement operator is joined, break it. Then you have x plus y complement. Again, plus changes to dot, ये complement joint है, break it. Okay. Next, if you have x bar plus y bar, क्या होगा? This is plus, this changes to dot. This is broken, you join it. अगर break है तो आप उसको join कर लो. So similarly, you can solve any expression no matter how complicated it is. Okay. अगर कोई सवाल काफी complicated भी हो जाए, still you will be able to solve it. Okay. Still you should be able to solve it. Next topic is we come to flip-flops. Next we come to flip-flops. Do you all remember the characteristic equations of flip-flops? Do you all remember the characteristic equations of flip-flops? Yes. Anyone? What were the different characteristic equations? Because you'll need that in the exam, okay? If you remember the characteristic equations. Don't worry, if you have not revised it this week, okay. If you don't remember immediately, no problem. Just go through it tonight. Tonight, go through your short notes. आपको सब याद आ जाएगा. अगर तुरंत याद नहीं आ रहा है, don't worry, don't panic. Okay. What were the characteristic equations? SR flip-flop. First one is for the SR flip-flop. We may perhaps never use this in an exam, but still, what is the characteristic equation of an SR flip-flop? S plus R bar Qn. Okay. Next, oh, not SR flip-flop. I should write this as Qn plus 1 is equal to Qn plus 1 is equal to, okay. Next, what was for a JK flip-flop? This is very, very important. Many times there's a question here. JK flip-flop के लिए क्या था? Qn plus 1. For JK flip-flop, it was J Qn bar plus K bar Qn plus K bar Qn. Okay. For D flip-flop, it's very, very, very easy. For D flip-flop, Qn plus 1 is simply is equal to D. Whatever is your input, that is your output. And finally, for toggle flip-flop, do you remember for toggle flip-flop क्या था? It is T XOR Qn. XOR, you remember the expansion? It is T bar Qn plus T Qn bar. एक बार इस पर बार, एक बार उस पर बार, T Qn bar. Okay. So you must remember the characteristic equations, then you will be able to solve in the exam. Okay. You have this in your notes, so you don't need to write it. I'll just write down a problem and then we'll solve this problem. And then this will be the last problem that we solve. A sequential circuit using D flip-flop and logic gates is shown below. X and Y are the inputs and Z is the output. The circuit is options are SR flip-flop. I mean, does the whole circuit behave as a SR flip-flop with X is equal to R, Y is equal to S, or does it behave as a SR flip-flop with X is equal to S, Y is equal to R? Finally, does it behave like a JK flip-flop with X is equal to J and Y is equal to K? Or does it behave as a JK flip-flop where X is equal to K and Y is equal to J? Okay. Now let me give you the diagram very quickly. I'll draw the diagram and then you can try solving it. I mean, I'll explain it. No worries. There is a logic gate over here. AND gate hai. Another AND gate over here. Both AND gates are then given to an OR gate. An OR gate is given to a D flip-flop. This is the output. This output is called Z. This is called Z bar. Okay. This has a clock pulse coming in. Okay. The inputs to the logic gates are, this is an input X. This is an input Y. Okay. Next, Z is given as the other input to this logic gate. See, these types of questions we have seen some PYQs also. So all this requires is a good understanding of characteristic equation. And finally, what they are saying is this whole thing is enclosed in a box. ये पूरा का पूरा एक बक्से में बंद है. Now they want you to know that what is this flip-flop? 2 inputs, 2 outputs. This is the box and they want you to know what is the flip-flop. Okay. Yes, let us try and solve this. All right. Let's start with the first logic gate. See, this is Q, right? ये Q यहाँ आया. So this is Q. This is X bar. This is an AND gate. So this will become Q dot X bar. Correct? This is Y. This Z bar has come here or Q bar has come here. So I can write this as Y into Q bar. There is an OR gate. So finally I can write Q into X bar plus Y into Q bar. This is the input. This is the input to the D flip-flop. Now, do you remember the characteristic equation of D flip-flop? D flip-flop का characteristic equation क्या था? For D flip-flop, Qn plus 1 is equal to D. D की वैल्यू कितनी है? Q into x bar plus Q bar into y. Okay, I'll write it this way. Q into x bar plus Q bar into y. So final output is this. This is your final output. ये किसके characteristic equation को resemble करता है? Whose characteristic equation is it resembling? See, only JK flip-flop has something like this, right? So if I write the JK flip-flop characteristic equation, what do I get? I have J, acha, theek hai. Just below this I'll write so that it becomes more easier to identify. You have J Qn bar, I'll write it here only. J Qn bar plus K bar Qn, right? J Qn bar plus K bar Qn. If you write it in this terms, you can write this as K bar Q plus Qn bar into J. Okay. अब ये क्या लग रहा है आपको? X is behaving as K and Y is behaving as J and the whole thing is behaving as a JK flip-flop. Correct? The whole thing is behaving as a JK flip-flop. So which is the right answer? Option D is the right answer where X is K and Y is J. Is this problem clear to everyone?
Yes.
Okay, just write this down. Now just some, okay, you just finished writing this. Then I just want to say a few things more about the exam and electronics in general. See, I know that ideally 2 hours is not sufficient for, the whole revision of the whole syllabus. That way, even electronics is one of the smaller subjects, but still there are a lot of topics. Like we did not cover multiplexers, we did not go into K maps, we did not do any problem on comparators. So I would ideally like to do a lot of more problems, but there's a limit to how much we can do in 2 hours. Okay. But the main bottom line is you don't need much of revision, like many problems right now. All the problems that we have done in your notebook, trust me, they are sufficient. As I told you again, once again, I'm repeating, I'm not saying that you will be able to solve every single thing in the paper. I'm not saying that. There is always a chance that something they ask is outside what you have learned. There's a possibility. But having said that, I do believe that we have a strong core of a lot of problems we'll be able to solve with the knowledge that we have. Just be cool and read the question carefully. Try and make connections in the question. Oh, this looks very much like this. This looks very much like this. This question, I know something about transistors. Just like the TIFR question that we saw. Okay, there's an LED or something. But do I know how to solve transistors? Okay, now let me read the question again. Do I know what is IC? Okay. Do I get from IC to IB? Oh no, there's no beta given. Anything else for me to find out beta? That is how you solve it in the paper. Basically, this is a game of how well you are able to connect. Okay. So, jitna aap connect kar paoge exam mein, that will happen if you pause and think coolly. Okay. So that is one thing that I would like to tell you. Second thing that I want to say is for the exam, especially for the exam day, this is my personal advice. This is what I used to do when I was a student, and I have seen many, I have given the same advice to many students. When you solve your paper, please start by solving some really easy questions. Don't start solving sequentially. If you choose aptitude, since this is for a net exam, aptitude and physics is clearly part A and part B, part C is separate. Whether you choose aptitude, whether you choose physics is up to you. I personally would start with physics, but that's a preference. I'm not asking you to do that. But the second thing I am saying is helpful. You must follow this. That is, start with 1 or 2 questions which are really easy. See, in every single subject, there are some questions that are very, very easy. For example, electronics, man. if there is a question on negative feedback of an op-amp, if there is a question on clippers, if there is a question on logic gates, Boolean algebra, these questions are very easy. Similarly, in nuclear, if there is a question on particle physics, or in mathematical physics, if there is a question on eigenvalues, a matrix is given, some options are find out the eigenvalues. You know that the sum of eigenvalues is equal to the trace, the product of eigenvalues is equal to the determinant. These are very easy questions. So to give you an analogy from cricket, when you start playing a match, first ball, if you get a very simple ball and if you just play it, suddenly you feel settled. Oh, chalo, मैंने एक ball तो मैं play कर लिया. So these are like very simple questions. Always start with the simplest questions, just so that your nerves settle down, because on the day of the exam थोड़ा सा pressure ज्यादा होता ही है. If you start with a very simple question, what will happen is that will settle down. And how do you find these questions? Read through it. Don't think about solving everything. Just very quickly read through it. Can you find a circuit? Can you find a particle physics question? Can you find a eigenvalue question? That way, whatever works for you. Perhaps one of the questions that you find easy is from quantum mechanics. Depends on you. Some of you might find complex analysis questions very easy. Good. Statistical mechanics. Some of you might feel, oh, Ising model, I can solve it immediately. Or some partition function is asked, I can calculate it like that. Whichever is your favorite subject, whichever is your favorite topic, whichever you feel is the easiest question that you can attempt that question first. Once you get one question, your nerves will settle down. This helps a lot. I remember in the first serious net exam that I gave, I started, and there was one question on transistors that I solved. Then I settled down. Till then, I thought that I could not solve anything. Then when I read it for a second time, I saw, oh, I was able to solve more questions. So, हमारे nerves settle होने के लिए, there is one question that we should solve. We feel good. We feel good. Where you solve it from doesn't matter. आप part B से start करो, part C से start करो. That is a preference. I'm not saying this. Next, when you solve your paper, in the first round, let's say a 3-hour paper, half an hour is for aptitude, for example. Again, it's up to you, but I would say, let's say half an hour is devoted to aptitude. So you have 2.5 hours to solve physics paper, right? The first 1 hour you should give for those questions which are easiest and which take less time to calculate, not the long calculation ones. Okay. For example, in quantum mechanics, you have a problem on variational methods, right? Variational theory pe jo question aata hai. Sometimes you know that those questions are long to solve. Some problems from ED, they might take you some time, a lot of integrations to be done. Some problems from mathematical methods, you can solve it, but these are long calculations. Please avoid them in the first round. When you go to the exam, when your mind is fresh, don't start with the most difficult ones that you don't know the answer to, and don't start with lengthy calculations. Start with the small calculations and the ones that you are most confident about. इसलिए first read the paper, read the whole paper, and mark. See, it's an online exam. It's very good. You can mark this. This is marked for review. This is marked for review. वो color change हो जाता है ना? I think it changes to that purple color if you mark it for review. So solve those questions first. So first 1 hour, you should always solve the questions that you can easily get, the low hanging fruit. जो आसानी से, don't keep this for the end. Oh, this I'll do at the end. You will 101% mess up. Please don't do that. In the first 1 hour, in the first round of solving questions, solve these. Second round, solve the long calculation ones, which you know you can solve, but it will take 5 minutes, 7 minutes, or it is going to, like, it is slightly tricky. You can do it, but you will take some time. This is what I would really advise, because what happens is when your mind was fresh, a lot of the bulk of your scoring is done. Sometimes you might come very close to the cutoff in the first round itself. Okay, let's say the cutoff is 80 marks, even without aptitude. Let's say you are going to get 20 marks in aptitude and you are aiming for a score of 90. 20 हटा दिए 70 mark में से. If you do the first round well, you should be able to get to 45-50 marks easily. Okay, if the paper is like you're in a good zone, you'll be able to get there in the first round. Second round mein bade calculations, slightly tricky problems. In the third round, you do those that you have no idea, but you want to attempt, just like the TIFR question that we solved. Transistor का सवाल है, immediately तो नहीं solve हो रहा. Exam के दिन भी, I am sure that it will take you around 5 minutes to figure out the answer. Keep that for the last round. Keep that for the last round. First solve the easy ones. Okay, if you do that, this Finally, what this will do is this will help you to maximize your maximize your score. Okay, and most importantly, if you don't if you are not able to get 3 4 5 questions consecutively, you need question 1, you don't know it, question 2, no idea, question 3, no idea, question 4, no idea, question 5, no idea. Don't panic, doesn't matter. Even if you don't get 4 5 questions successively, there's no problem at all, there's still time. Okay, see, the cutoff is not like 90% and all, cutoff is around 50%. If the question paper is difficult, less than 50%, you have time. And remember that you have worked hard for 6 months, for 1 year, you know things. Only thing is there you might not be able to recollect immediately. Wait for some time. Try to go through that section in your mind. You will get it. So don't panic. The more you panic, the more you will make mistakes. So please don't panic. I know this is like very basic, repeated advice, but this is required. Don't panic during the exam. Okay. And as for electronics, one day before the exam, please go through your short notes. Only through your short notes. No problem solving for electronics one day before the exam. Okay. Monday exam hai, to Sunday raat mein please don't solve any problems. Just go through your short notes well. That should be sufficient. This week, however, go through the PYQs in your notebook. If you go through the notebook, all the PYQs, if you solve, you're good to go. Okay. So all the very best. Do well. God bless you. Yeah, that's all. Any doubts in today's lecture, please ask me. If not, you can leave. Okay. I'm not teaching anything new.
Thank you, sir.
Yeah.
सर
हाँ, yes, अभिषेक.
चैट देखे मैंने कुछ पूछा है थोड़े पहले
अभी पूछा है.
नहीं थोड़ी देर पहले पूछा था 39 पे तो 39 पे
Oh, in gates, there was a mixed question of logic gates and nuclear physics. Oh, interesting.
सर वो क्वेश्चन ऐसा था कि उसमें दो डिटेक्टर लगे हुए थे
Okay.
D1 and D2 अल्फा एंगल क्रिएट कर रहे थे एंड दे वर आस्किंग द लॉजिक गेट व्हिच गिव द रिजल्ट और
Okay.
उसमें सर ऐसा कुछ भी नहीं था कि डिटेक्टर कौन से हैं बस ये था कि हाँ पार्टिकल अल्फा है शायद या नहीं अब कैसे होगा वो तो मुझे बिल्कुल समझ में आया
Okay, okay. I'll just wait one more day. I don't know. Today the response sheet is supposed to be out yesterday, I think. I'm not sure. Once I get the PDF, we'll anyway share a solution in the group also. So you'll get it, okay? But let me see the question. I don't know the question yet.
दिस टाइम क्वेश्चन पेपर गेट वाज अ बिट डिफिकल्ट आई सपोज क्योंकि सर पूरे पेपर में क्लासिकल मैकेनिक्स के अलावा क्वेश्चन नहीं थे ज्यादा क्वेश्चन किसी इलेक्ट्रॉनिक्स का सिर्फ एक ट्रांजिस्टर का क्वेश्चन था जो डायरेक्ट सॉल्व हो रहा था 2 नंबर का था वो डायरेक्ट सॉल्व हो रहा था लेकिन बाकी क्वेश्चन सब सिर्फ ये इस पे ही थे वो भी ऐसा नहीं कि हैमिल्टोनियन दे रखा था लैग्रांजियन पूछ रखा था और कंटिन्यू इक्वेशन पूछ रखा था एमएसक्यू में पूछ रखी थी इक्वेशन मतलब
Oh,
पूरा सॉल्व करना पड़ेगा उसको
okay, okay, okay.
वो तो हुआ ही नहीं फिर लास्ट मोमेंट तक नहीं हुआ
No worries. If the paper is really tough, the whole cutoff comes down. So that is not a big cause of worry. Like if you've solved even some part of it, when the paper is really tough, there's still a chance for you to qualify if you have even done the bare minimum.
फिर कुछ क्वेश्चन तो ऐसे थे जैसे डायरेक्ट पूछ लिया था जैसे न्यूक्लियर फिजिक्स में 2 क्वेश्चन पूछे थे उन्होंने एक क्वेश्चन पूछा था स्ट्रेंजियस नंबर पूछा था कि -1 किसका होगा 4 ऑप्शन थे ये क्वेश्चन डायरेक्ट था और एक क्वेश्चन था वो उल्टा ही था एकदम वो तो
Okay.
पता ही नहीं चल रहा था कहाँ से आया है
But anyways, don't let that, like, उसको दिमाग में मत रखना. अभी नेट पे पूरा ध्यान दो, क्योंकि इतना अगर 6 months कंटिन्यूसली पढ़ रहे हो, उससे भी ज्यादा शायद, पता नहीं, बट should be able to give this paper with a fresh mind. Okay.
पिछले 2-3 महीने में सर सारे शॉर्ट नोट्स बनाए हैं फॉर्मूला शीट रेडी की है क्वेश्चन पेपर सॉल्व कर रहे हैं देखिए क्या होता है
Yes, yes. No, don't worry. All the best. Do well. God bless. Okay. Okay. All right then. All the very best. Okay. I'll end.